In this vlog, skills versus capacities in speed and agility, two athletes will perform a 10-meter acceleration and a 5-10-5 change of direction drill. I'll spend more time analyzing the 10-meter acceleration, where I will make considerations that apply to both drills. In my analysis of the agility component, I'll then focus mostly on characteristics linked to the change of direction. To define skills and capacities, I have used the following definitions given by Daniel Kleder. A skill reflects the athlete's ability to control their body accurately, efficiently, and in a timely manner, where a capacity is the athlete's ability to express a given quality, such as force or mobility. For each performance, I'll analyze the movement, highlight the critical issues, present my interventions, and provide training recommendations. Both a lack of mobility and of force production limit athlete number 1's acceleration. Let's have a look. A lack of piston-like movement of the legs leads to a high foot recovery. This is an ineffective strategy in acceleration where the key is to maximize ground contact time. It is caused by a lack of horizontal propulsive forces, and as a consequence, the athlete loses his optimal acceleration angle. A vertical body position can be seen in the third step already. Another consequence are excessively long steps, leading to a negative touchdown distance and an increase in braking forces. Excessive adduction and internal rotation of the hip can be seen better with this view from behind. It is a movement solution used by sprinters to move their knees higher. However, it can also be the sign of tight hip flexors. In a wall drill, we see that he chooses quite a vertical lean. He is able to hold a fairly good position, which he can't maintain once movement is integrated. A lack of strength and stiffness is again evident when the movement is performed more explosively. A screening shows the athlete has an anterior pelvic tilt, which limits his knee drive. Tightness of the hip flexors, especially the rectus femoris, can be observed in this Thomas test. To correct the anterior tilt, I suggest stretching the hip flexors, strengthening abdominals with a reverse crunch, as well as strengthening hamstrings and glutes. I also recommend working on maximum strength, as well as on vertical rate of force development with loaded continuous jump squats. Ankle hops will improve stiffness. I also recommend working on horizontal propulsive forces with banded starting steps, bounding exercises, and resisted accelerations. Athlete number 2 is an ice hockey goalie. A lack of sprinting skill can be seen in his performance. He adopts a starting position with feet too far apart, with very little positive shin angle in his left leg. He then fails to stay big with an insufficient anterior arm action. An open knee angle means he has a negative touchdown distance from the first step. As a consequence, he gets more vertical and has a high foot recovery, looking more like high-speed running after 3 steps only. The external rotation of the hip will have to be looked at, but it could simply be a habit from pushing sideways on the ice. There is also a lot of lateral movement in his arm action. In a wall drill, the athlete gets in a solid acceleration position with a good lean forward, a stiff body, and better knee angles. He is also able to perform a good load and lift. However, with faster movements, the back leg tends to lose stiffness and control, with a tendency to externally rotate the supporting foot. A screening shows no issue with hip flexion as well as with ankle mobility. Thoracic mobility is not an issue for arm movement, neither are shoulder internal and external rotation. We can exclude glute tightness as a reason for hip external rotation, and a hip strength assessment shows no imbalance explaining the external rotation. This athlete demonstrates high levels of strength and of rate of force development, critical for acceleration. He also has the ability to produce high horizontal propulsive forces. Therefore, we need to develop his running skill. Exercises like marching and skipping can serve a double purpose: a smaller knee angle and a foot contact under the center of mass. Finally, hill sprints will help him feel closer to the ground. For athlete number 1, insufficient lower body and core strength are capacity issues hindering his change of direction ability. A lack of strength is seen with the minimal distance covered by his first step, with hardly any push from his right leg, and again with how much deceleration is needed before making the turn. Core strength is an issue in the change of direction, as seen here in how he gets squeezed down during the turn, failing to resist both flexion and rotation. For this reason, I recommend strengthening his posterior chain with exercises like the Romanian deadlift, working on anti-rotational strength with the lateral cable walk, and strengthening anti-lateral flexion in both a high and a low position. For better relative strength of lower body, I recommend a unilateral exercise like the Bulgarian split squat. Finally, I would work on rate of force development in lateral movements with a progression of bodyweight jumps and resisted exercises. Coordination issues are critical to athlete number 2's change of direction ability, and my suggestion is that these are linked to his ice hockey goalie background. Goalies don't cross over, have little arm action to stay compact, and can push off their skates inside edge more aggressively than with shoes on. To start, a crossover would likely be more appropriate, as it leads to more horizontal distance. There is also very little arm action on his right side. Here, he holds both hands in front of his body, which is again a typical position for a goalie. The way his foot slips at both turns is a consequence of an over-aggressive angle as well as inadequate shoes. A progression of lateral steps and jumps is appropriate to improve both foot contact stability and arm action coordination. Always more dynamic to finally use them in a speed drill. In conclusion, skill and capacity issues are often linked and they evolve together. Both athletes had similar technical issues that were caused by different limitations. Therefore, a critical individual analysis is always required to set an athlete's priority.